growing cotton here since the early 90s. My first introduction to cotton, I guess, was about 10 years before that. There was lots of chemistry used, lots of early generation chemistries that were not environmentally friendly at all. The system in those early days was basically, you know, if it moves, spray it. We didn't know. We didn't know what we didn't know at that time. Through Bollgard 2 and now into Bollgard 3, I mean, the product works great. From the time that plant emerges, you kind of know where you're going with it. It's certainly important to be on top of stewardship and maintain this technology, extract as much as we can out of it, but also put in some effort to maintain its integrity and you know, stay ahead of the curve.
We've developed a resistance management plan with industry to delay the evolution of resistance in Helicoverpa species to the insecticidal proteins in Bollgard 3, Cry1AC, Cry2AB and VIP3A. And we measure how that resistance management plan is working through our annual resistance monitoring program. This year the team has focused on F1 screens, which means we have collections of Helicoverpa eggs come in from the field. We rear them up to adults and then we pair one of those with a known resistant colony. We screen their offspring against the protein that the lab colony was resistant to. And if around 50% of them survive, we know that the individual from the field was a heterozygote. So it was carrying one resistance allele to the protein that we have screened it against. The other screen that we've been focusing on this year is our F2 screen, where a male and a female from a field collection are mated together. We rear their offspring, we sibling mate them, and then we screen the offspring of that generation against all three proteins that are in Bollgard 3. We use the resistance monitoring data to understand if there has been a change in resistance allele frequency each year. If we see over a period of time that resistance allele frequency is increasing to any of the proteins, it gives us the opportunity to consider making changes to the resistance management plan if needed, so that we can protect the technology into the future. The F1 Cry2AB resistance allele frequency this year for Helicoverpa armigera is 0.015, or around 3% of the population which carry one resistance allele for Cry2AB. And for Helicoverpa punctigera it is 0.002, or around 1% of the Helicoverpa punctigera population carrying a resistance allele for Cry2AB. The results for the F1 screens for VIP3A for Helicoverpa armigera this year is 0.004, or again around 1% of the population, and for Helicoverpa punctigera is 0.005, also around 1% of the population. Resistance alleles to Cry1AC remain rare in both species. For the F2 screens this year, we identified no positives for Helicoverpa armigera for Cry2AB or Cry1AC, and the resistance allele frequency we identified for VIP3A for armigera was 0.008. We had the same results for Helicoverpa punctigera this year, where we identified no positives for Cry2AB or Cry1AC, and the resistance allele frequency for VIP3A was 0.002. So what we understand from this year's data is there's been no change in resistance allele frequency for either species to Cry2AB or VIP3A. We see no evidence of cross-resistance. So what that means is when we identify a positive when we do our F1 screen is we take those families through and we do further screens to identify if there is any cross-resistance to any of the other proteins in Bollgard 3. None of the individuals that we identified as positives in our screens are resistant to Bollgard 3. They only carry one resistance allele to the insecticidal protein that we have screened them against, so they're not resistant to Bollgard 3. We will continue to run an annual resistance monitoring program. To conclude, the data for this year really reinforces that the resistance management plan is robust, and also all the efforts that growers put into being compliant and making sure they plant refuges, look after refuges, do great end of season management, and it's really down to that we want to make sure we have a robust technology into the future.